Hello everyone. We are given two strings S and P. Our task is to find anagrams of string P in string S and then return all the start indices of string S where the anagram of string P are found. Anagrams are basically words that have the same letters but are not necessarily arranged in that same order. And without further delay, let's get into the constraints to understand more about this problem. First thing is S and P consists of only lowercase English letters, so we have to consider no other characters. The second thing is how long can the strings be? They can range from 1 and can go up to 30,000 characters. Okay, so now coming to the approach, we use mathematics to solve this problem. We use hash, which is a random number computed with the help of a complex mathematical function. We calculate hash of each letter and then use that to calculate the cumulative hash of the required string and then compare it to the cumulative hash of the substring. If they are the same, we add the start of the substring to our answer. Let's look at the code to understand this further. We start by checking if the length of the required string P is greater than the length of the string S. If it is, we return an empty list. The next step is to create a hash table of all alphabets, which can be done using the hash function, and a string containing all alphabets and mapping each hash with its respective value, and then have an empty list to store your answers. We then use two pointers to track the substring inside our given string S. Our approach here is to use hash of each letter and add it to the existing hash value of the substring and check if the hash value of the current window is equal to the hash value of the requested string. If it is, we add the start position to our list. After adding that value, move the window forward by subtracting the hash value of the left letter from the current hash and then incrementing the left pointer. In the end, return the list of the start of the anagrams if there were any. Now, let's look at some of the test cases to see how this worked. To understand the time complexity, let's look at the code closely. Calculating the hash values of the letters of the alphabet take a constant time, as there are only 26 letters. The next is the for loop, which is dependent on the length of the string. If the length of the string is n, the time complexity will be O of n. The space complexity is constant. The hash table, which is dictionary in our case, consists of 26 values, so that is constant. And in the rest of the code, we keep reusing variables, so they are also taking constant space. If we exclude our answer list from our calculations, the space complexity will be O of 1, which is constant. And that was it for the video. I can't think of a way to change this problem. Please let me know in the comments below if you can. There are also links to similar problems in the description below. Please like my video and subscribe to my channel if you found my content useful. I will see you next time with a more interesting video. Until then, bye.